Hey, thank you, Melody. I appreciate that. Yeah, let's give a hand for Melody. Okay, fantastic. So today we're going to dive into a little bit about fats. So Melody did mention some of this, so I'm going to go through this pretty quickly. We have 3 different categories of fats. There's unsaturated fats, saturated fats, and trans fats. You really want to stay away from trans fats. Saturated fats you still want to stay away from because they're pretty unhealthy. You can tell that they're saturated because at room temperature they're still solid. Whereas healthier fats, that's your monounsaturated fats, so like avocados full of monounsaturated fats, which is why if you were to squeeze it into the oil, it's liquid at room temperature. Protein, we are going to come back to this, but I do want you guys to take note on the top left, right there, where it says half a gram to 1 gram per kilogram per day is what the average person is recommended for their protein intake. That seems very little, right? That is the true recommendation of the amount of protein that we should be having in our diets. In fact, there was a study over 120 years ago proving that that was the case. Unfortunately, because of certain industries like the dairy industry, meat industry, and so on, there's been a lot of individuals who have put out articles, publications, all sorts of things saying that our protein intake should be way higher than that. But we're going to take a look and see why that is really not the case. So there are some things that are related to too high of a protein intake or too high of a saturated fat intake and trans fat intake. That would be things like bone health, liver problems, kidney problems. So if you want to prevent osteoporosis, which is having brittle or weaker bones, taking in vitamin K is really great. Also calcium, the top 2 things. Actually, I'll ask you guys, when you go vegan or plant-based, what's the first question that people ask?
Protein.
Okay, great. Then what's the second question they ask? Yes, where do you get your calcium? So things like collard greens, kale, mustard greens, spinach, all of those things have calcium. And for your vitamin K, you've got spinach, broccoli, kale, Brussels sprouts, and so on. Things like liver disease that can lead to cirrhosis, having too high of a meat intake, this is something that can lead to the cirrhosis of the liver as well as issues with your kidneys. Especially with meat, we're going to come to this in a second, but especially with meat, when meat goes through the body, because meat does not contain any fiber, the bacteria inside of your belly, I can't remember exactly, in your gut, in your gut, is looking to feed on something. And so because there's no fiber for it to feed on, the next thing it feeds on is the meat itself. And so the meat actually starts to putrefy and it literally rots inside your stomach. It's very disgusting. And that's why carnivores in the wild, they have very short digestive tracts so that the meat can pass through quickly so it doesn't putrefy. We as humans, we have very long digestive tracts, meaning we are made to eat plants because plants go through slowly, but the bacteria gets to feed on the fiber so it doesn't rot in our stomach. Obesity, of course, when it comes to eating meat, a lot of meats actually have less protein than they do fat. So beef, if I'm not mistaken, is I think 40%, depending on the cut, but 40% protein and 60% fat. Chicken, if you take off all the fat and all the skin, it's still about 20% fat, 80% protein. And then of course there's no fiber in there to help with buffering some other things that we're going to talk about. So some complications: diabetes, heart disease, stroke, sleep apnea, hypertension, liver problems, gallbladder problems, depression, and other things. So what cholesterol does to the body, it clogs up the arteries. I know the slide here says that there will usually be no signs of disease until the artery is 90 to 95% blood. You can die of a heart attack prior to your arteries being 90 to 95% clogged. If you end up if you're at about over 50% of your artery being clogged, and something happens where a blood vessel ruptures, or there's an ulceration in an artery or a vein, white blood cells and things that help with inflammation will flock to that site, and that will further go. It'll go from 50% clogged to close to about 100% clogged. So people can die without even having their arteries completely clogged. So you can have somebody who looks completely healthy. Personally, I think this is why a lot of fitness influencers are starting to die at pretty young ages. They look very healthy, but on the inside, they have arteries that are somewhat clogged, and they get something, for example, like COVID, causes inflammation, and then they succumb to the disease. Kidney problems, very much like what we mentioned with meat, it putrefies the kidneys. That's where all of the toxins are stored and getting ready to be released. So you can have some really big problems there. Melody spoke about drinking water and how much that helps with these risks of like heart disease and kidney disease and many other things. So I won't go through too much of that. That is not quite the end. I actually want to get to some more of this stuff. So don't necessarily worry about this, but I just wanted to show where amino acids actually come from. So it's called amino acid synthesis. And so plants are the only thing, plants are the only thing that actually make protein. Animals do not make protein. So this slide here, this slide is basically just showing that plants take the nitrogen from the air, and it's the plants that actually turn this nitrogen into all the different types of amino acids that are present in the world. So if you think about it kind of like the alphabet, amino acids are just like that. You have a dictionary. A dictionary, there's only 26 different letters in a dictionary, but they're always rearranged to make all these new types of words. So that's basically what plants do. They take nitrogen and then they rearrange it into different forms, and then animals go and eat them, and then people can get these amino acids, protein, from these animals, but they're skipping over, or we can skip over the middleman and we can just get it directly from plants. Thank you for bearing with me and me talking so fast, but I really want to get through all this. So I want you guys to think about the building of a body like building a home, and this will help solidify the understanding that we really don't need as much protein as you probably think you need. And a lot of people here, probably even including myself, a lot of people here are way over their protein requirements for each and every single day. So building a house is likened to building a body, and proteins are your building materials. So when it comes to building a house, you need to deliver the building materials at the rate that they're going to be utilized. So if I'm building a house and I'm going to take a year to build a house, I'm not going to order all the materials the one day. I'm just going to have a bunch of stuff sitting around. But if I'm trying to build this house in 2 days, then I need to make sure that everything is there, or else my workers are going to be standing up saying, well, where's our material? We need to build a house. So the rate of delivery, in other words, protein consumption, should equal the rate of utilization, in other words, growth rate. So how long or how quickly that being, or in this case, the human being, is growing. So a completed building or a completed house needs decreased materials, meaning once I finish my house, I'm not going to order a whole new set of bricks. So adult bodies do not need large amounts of protein. Once an animal is mature, it only needs enough protein to maintain homeostasis. So if I have a leak in my roof, I'm not going to order new asphalt shingles for the entire roof. I'm just going to order for that little spot that was broken. So continued delivery of the building material to a completed building would mean that I would have a pile of rubble. Because if I have a hole that happens to occur in the side of my house, and I order all the amount of bricks that I need to build a whole new house, just to cover up a little bit of the hole in the wall, I'm gonna have a pile of rubble that's gonna be stuck in my front yard. And when it comes to the body, does anybody want to guess what that pile of rubble would be? Very good guess, but not quite. It would be a tumor. It would be a tumor. And we don't want tumors. So you could have things like lipoma, right? In more bizarre situations of the additions to the house, you can get cancers, and we definitely do not want cancers. So really quick, because my time is running out, we're going to go into protein and carbohydrate metabolism. I think this is probably the most important slide. So if you're going to remember anything, please do remember this. There's only two main ways that protein can be used in the body. I'm going to get you guys to all say something with me in a little bit, but I'll explain it first. So protein, the first way it's going to go is it's going to go into structure reformation. So that's through enzymes, hormones, neurotransmitters, and especially body tissue. So if I go to the gym, I work out, then that protein is going to be used to help rebuild some of the muscle. Once the protein has taken care of structural damage, if there is excess protein, what happens is it's going to get converted into carbohydrates. I believe this process is called gluconeogenesis. Basically, and the body really doesn't like to do this because it takes a lot of energy to, the body is going to break down the protein into carbohydrates. Now, let's start with animal protein. When you do this with animal protein, it's extremely dangerous because something gets released. So I think it says it here. Yeah, so basically the carbon backbone of the amino acids gets broken off and it releases something called sulfurous acid. Now sulfurous acid, it's not like sulfuric acid, which would literally destroy you, but sulfurous acid is still pretty dangerous. It will erode and destroy your body just over longer periods of time. So what's gonna happen though is your muscles are actually gonna need to excrete calcium phosphate. And so when your muscles are excreting the calcium phosphate to bind to this sulfurous acid so that your body doesn't get damaged, that's what leads to osteoporosis, because now you have weaker muscles, more pressure is being put on your bones, and then you get weaker bones. So it turns into carbohydrates. The carbohydrates can be used for energy because the body prefers to use carbohydrates for energy first before turning it over to building material for body tissues. The last thing it's going to do, which again it really doesn't like to do this, but it can also store these new carbohydrates as glycogen. But if your glycogen stores are too full, then the body will actually turn it into fat. And this is even worse because not only do we not want fat, but it takes about 25% more energy for the body to create a fat cell. So instead of the body giving you energy, you're now having to fight with the fat cells for your own energy, which is really unfortunate. So this is what I want us to all say together. Our bodies cannot store protein. We're going to do it one more time. Our bodies cannot store protein. So once we get over, so an adequate protein intake is 0.5, you could round it up to 1 gram per kilogram. So I weigh 75 kilograms, so I would take in a day half of that, which would be 37.5 grams of protein to upwards of about, 60, I think like 68 grams of protein, something like that, or 65 grams of protein. And I ideally would not want to exceed that because then in my body, oh sorry, one thing I did forget to mention. The sulfurous acid, when you exceed in plant protein has a lot of calcium phosphate already inside of it, and so that can bind to the sulfurous acid. So it's not as dangerous, but again, you still don't want to exceed your protein limit because then tumors can still occur, and just generally speaking, it's just not really good to have excess of anything in the body. So there's no physical advantage for consuming more protein. All protein that is not utilized for homeostatic purposes is stripped for nitrogen and sulfur and converted into carbohydrates. Animal proteins, they're not buffered, so as we said, they can cause calcium to be taken out of the, this says, taken out of the muscles, and it weakens the bones, leading to osteoporosis. And then plant proteins, well, yeah, it's the same thing. Okay, so I always get the question, actually Jose and I were talking about this earlier today, but what if I'm super physically fit and I do all this exercise? Don't I need more protein? Don't I need to have the whey protein and the this protein and that powder and everything else? The short answer is no. Reason being, again, as we saw, our bodies cannot store protein. So once I pass the threshold of protein consumption, my body is just going to turn it into carbohydrates. And then it's going to start this whole cycle that we have over here. So what I really want to do is, if I am exercising or I'm getting a lot more physical activity, and if anybody wants to take pictures, I can actually send all this to you individually. So what I actually want to do is I want to increase my energy intake. How do I increase my energy intake? Yes, but through food. Through food.
Carbohydrates.
Yes. So I know we kind of hammered on fats, so it seems very counterintuitive. Why would I be saying we want to increase our fats? The reason being is you want to increase your polyunsaturated fats. So we can have things like walnuts, almonds, flax seeds, things that are good fats. Not all fats are created equal. And so ideally, if I'm going to create a percentage of what I'm going to eat in a day, I'm probably going to want to be around, speaking for me personally, I'm probably going to want to be around 65% carbohydrates, 25% fat, and then 15% or less protein. And then of course adequate intake of essential amino acids. I mean, if you're exercising a lot, you're probably eating more, and then that's just going to increase your protein intake anyway. I have like 2 more minutes, but this down here really shocked me. Most Americans, including, what does that word including mean? It means, exactly, they're grouped in together. So most Americans, including vegetarians and vegans, are getting equal to or more than 1.5 to 2 grams per kilogram a day, when they're really supposed to be having, so on the further end to the lower end, so the 2 grams per kilogram per day, to compared to the lower end of the adequate protein intake, they're getting 4 times as much protein than they're supposed to in a day. I personally remember when I used to count my protein intake before I knew all this, and every single day I was doing my absolute best to get into like 110 grams of protein, 125 grams of protein. I was basically trying to eat my body weight in pounds of protein. I was getting like 145, 160. It was ridiculous. I'm happy that I know this now, so I'm not killing myself. But yeah, I won't really go into that. This is kind of funny. So this is, it says the new food labels are a bit more candid, but don't let that scare you. You've got a bunch of meat products and it says prepare to die. But yeah, I'm gonna skip through some of this. Okay. All right, wrong signals lead to disasters. So, question for everybody in the audience. At what point do any of these animals, even though they're herbivores, at what point in their lives do they eat animal protein? Jose, you can't.
Do they eat, once they give birth, do they eat the placenta and not increase from the diet?
Maybe, but I'll put it a different way. At what point do they ingest protein? Might be.
When they,
Okay.
when they're babies.
Yes,
So
yes,
when they're babies,
yes.
they
When
eat
they're
their
babies.
meat.
So you were very much on the right track, Alyssa. But the reason is when they're babies because they're going to be drinking their mother's breast milk. So, but they only get it when they're nursing infants and they're going through rapid growth. In other words, animal protein is a potent growth stimulant in herbivorous mammals. So, skip through some of that. Okay, really quickly, last thing I'll say, and then we can move on here. But one thing that is one amino acid or essential amino acid that is found in both animal and plant foods is called leucine, and animal protein has higher concentrations of leucine. Now, before research came out about this, a lot of scientists thought that since animal protein had higher levels of leucine in it, that it was actually superior to plant protein. However, leucine is linked to upregulating TOR genes. TOR stands for, anyway, it doesn't matter what TOR stands for right now, but the point is TOR genes, they lead to cancer. And upregulate just means they get turned on. And so the more leucine a person ingests, the more likely they are to develop cancer. And so the reason why these baby infant animals will get off of their mother's milk once they are grown is because they don't need rapid growth anymore. So they start going to the plants, which you can see there's only enough leucine in the plants just to keep that homeostasis going, whereas in the animal products, there is lots of leucine for rapid growth because, for example, let's take something like rats. Rats double in size every 4.5 days as babies. I think cows double in size every 47 days as babies. Human babies take 180 days to double in size. So if you were to take a look, I don't have it in this slide deck here, but if you
180 days would be
6 months.
6 months, yeah, 6 months. So it's a much different growth rate for humans than it is for animals, which is why if you were to take the protein the protein levels of a mother's rat mother's milk is 10 times that of a human mother's milk, because the rats are growing at a much significantly faster pace. So the issue is with this is when you upregulate these TOR genes and you have increased IGF levels, that stands for insulin growth factor. Adult humans, everybody in this room would be considered an adult human. We're not doubling in size in 180 days. So the only thing else that's going to be doubling in size or rapidly growing is going to eventually be cancer cells. And you don't want cancer cells rapidly growing. So if you have relatives that eat meat, or if you still eat meat, which I'm not judging because I had many lovely years of eating meat. I say lovely because it tasted really good. But you probably want to let them know that this might not be the greatest idea, because they're basically, or I was basically on a roller coaster to cancer land, and that's not fun. So yeah, this I found really funny. Fast food folly says, I'll have half a pound double deluxe bacon steer burger, please. And he says, do you want a side of chemotherapy? So these are some really quick sources of plant proteins. And I don't have time to go through all this, but remember, okay, let's just say somebody like me, I'm supposed to have, even on the maximum end, I'm supposed to have about like 68 grams of protein a day. So if I have 1 cup of black beans for breakfast, I'm at 15 grams of protein. If I have some chickpeas for lunch, I'm now at 30 grams of protein. And then let's say I have some soybeans, 1 cup. Let's say I don't eat dinner, but if I did eat dinner, another 28.3 grams. Then on top of that, I'm probably having salad. I'm probably having potatoes. Do you know that potatoes are 10% protein? So 10% of all the calories in a potato is protein. So, and then these are some more things that you can get protein from. So as you can see, there's tons of ways to get protein from plants, and on top of that, we don't even need all that much protein. So if you know people who are like chugging down whey protein, any like protein drinks, they're basically making, I heard a doctor say it this way, they're making expensive excretions because they're just gonna pee it out, or the other thing it out. So I found this funny too. I'll end on this slide. A different perspective. So I know Thanksgiving's coming up, and so you have all the chickens and the turkeys saying, "Lord, we thank thee," because they're not going to get sacrificed by you. So I did have 3 questions really quick. The first question, and we won't necessarily do this in a group discussion, so whoever wants to just put up your hand, you can answer. First question is, what are herbivorous mammals smart enough to do when transitioning into adulthood that many humans aren't? Yes, and stop taking animal protein. Yes, absolutely. What is the recommended amount of protein per kilogram of weight for an adult human? Yes, 0.5 to 0.8 or 0.5 to 0.1. You could stretch.
To what?
Sorry, to 1. To 1.
Not point one.
Yeah. I mean, yeah. And then, yeah, what are some options of plant-based protein? Yeah, nuts. Yes, potatoes, lentils. Yeah. Honestly, virtually everything has protein. Yeah, even like your spinach, your kale. All the leafy greens have proteins as well. It's just they're very filling, so it might take you quite a lot of those to eat. But yeah, all in all, I hope this made sense. I hope this gave you folks a little bit of a different perspective on protein and some information that can equip you that, when you have people coming around saying, "Oh, you're plant-based, how are you gonna get your protein?" You can let them know that nobody dies of protein deficiency in the hospital. I've never ever gone to, I've gone to visit people who are dying of like diabetes, cancer, all sorts of other things, autoimmune diseases. I have never once been invited to a hospital where there was a patient that was dying of protein deficiency. So, anyway, any questions?
Yes, wonderful.
Okay.
Why does it come back on that when people ask you about the protein? I heard somebody say, then you should ask them, where do you get your fiber? Do you get enough fiber?
Right. Yeah. You can tell them to think about that while they're on the toilet.
They usually don't.
The question is like how many cups of things we can eat and don't go overeat, like 3 a cup and a half or
Yeah, you'd probably be pretty safe at like a cup and a half. I mean, again, the nice thing with plant protein is you're not getting the damaging effects of like the sulfurous acid. Of course, yeah, you still do want to eat in moderation. So yeah, a cup and a half, you're probably pretty good around there. As well, a lot of studies have shown that eating in a calorie intelligent way, but eating in a calorie restricted diet does increase longevity. So even people who are vegan and vegetarian, but they're consuming lots and lots of food, it does put a lot of stress on the body. So yeah, typically, but yes, yeah, to answer your question, yeah, one and a half should be. Okay, I think we're gonna. Yeah.
Well, I was a dietitian for 22 years before, I started doing other things. But one thing I've been really concerned about, because this information, we didn't have all the little details and stuff, but we had basically the breakdown. And we knew a vegetarian, vegan diet was healthy for your heart and all that. One thing I've been so concerned about is the way Americans have gravitated and been indoctrinated to believe that we have to have all this protein,
Right.
excess protein. And I even have doctors, over the last 10 years, tell my husband, you need more protein,
Right,
you need
right,
more
right.
protein. And then an endocrinologist was trying to push protein supplement on both of us.
Yeah.
And she said that it really will prevent diabetes.
Yeah.
And why are doctors, are they being indoctrinated
Yeah.
similarly
So
and
that-
lied to?
Yeah, so that's a great question. So I'll give you an example. So I grew up in Toronto, in Canada, and there's a pretty relatively well-known university, at least in Canada it's well-known. It's called McMaster University. And all the doctor and nursing students, they study in a specific part of that campus that is called the Monsanto Wing. And I don't know if you guys know what Monsanto is, but it's a drug company. And so, you know, that says a lot already. So typically, you know, when doctors are going to medical school, no fault of their own, but they have so much information to learn. And so two things occur. The first thing that happens is they think, well, I have had maybe like 3 hours of nutrition classes, so if they didn't teach me it, then clearly it wasn't important. And then the second thing that typically happens is when they're taking a look at things like diabetes or inflammation or whatever else it is, the class goes something along the lines of, this is inflammation, this is what inflammation does to the body, and this is the drug that can be prescribed to take away the pain or the inflammation or whatever it is. And because there's so much information and they're assuming that they're only going to get what is necessary and needed, nobody stops to ask the question, well, where does the inflammation come from? And so because it does get kind of glossed over, once they're out of med school, there is, I'm saying this purely in my opinion, but I think there is this sort of idea or understanding that, well, I've already learned everything I need to learn. And oh, one last thing. When it comes to food studies, because they haven't done so many nutrition classes, when they actually get a report or when they're looking at a clinical trial and it's a nutrition one, in their minds, again, I'm kind of speculating here, but in their minds, they're thinking, well, I didn't look at enough clinical trials on nutrition during school. I don't know if I'm going to know how to interpret this. I'm just going to gloss over it and I'm just going to stick with what I already know, and I'll leave that for somebody else. And so there isn't really like a continued education type of thing once people are, again, that's purely my opinion. I could be wrong on some of those things, but.
Yeah, but then what I feel is like the dietary guidelines and then the recommendations that are being put out there are way too high.
Right.
And so is that fraudulent?
Yeah, so it's kind of hard. Like there was a Dr. McDougall, I think his first name is John McDougall. He had a fight with the American Heart Association. They had put out a statement basically saying that animal protein is the best place to get your protein, because with plant proteins you're gonna have to like mix your protein. We didn't really get into that, where you're gonna have to mix your amino acids. And then he made a public article and basically said that's not true, and he cited a bunch of papers. And the lady who was in charge of the AHA at that time, she basically wrote him back publicly saying that he was wrong, and she cited a doctor, which, funny enough, he called this doctor up, and eventually he finally got through to the doctor, and that doctor who she had cited basically said, no, they're wrong. All of my articles and evidence and things that I've done have proven that they're not true. So eventually they did take it away. But yeah, you see all sorts of crazy things, like you can go on, I don't know if it's still there, but you can go on like the diabetes website or like cancer prevention, and they'll literally recommend getting off of red meats and switching on to white meats, which are still carcinogenic. So yeah, I mean, I just don't see a way that they're really gonna get in trouble, and there's kind of no money in suing them because they have all the money. So education is the only way to battle.
So my mom died of kidney, her kidneys after an automobile accident when it destroyed. So I started reading everything, and I came across a YouTube video of a doctor who was a urologist, and he was speaking to only doctors, a whole huge stadium full of doctors. And one of them started raising their hand saying, when is the public, when are other doctors going to hear what you're saying? Because we're killing ourselves with too much protein, we're killing our kidneys.
Yeah.